But we're going to talk a whole lot of things with the Naked Scientist. And of course, you are going to be showing us some direction in terms of the conversation. You're going to be asking the questions. That is the opportunity afforded by the Naked Scientist, Dr. Chris Smith. Chris is a doctor, a scientist, is host of a widely popular Naked Scientist segment, and today is once again with us to answer all your burning science questions. He joins us all the way from the UK via Zoom. Welcome back, Chris. It's good to have you always.
Yeah, great. Good to be here.
I've got Janus on the line. He's from Feshuk. Janus, please go ahead with your question.
Hi, good morning, Clarence. Good morning, Chris. How it's possible, Chris, that when our solid core reversing the direction of the running of the solid core is the opposite of the our Earth directions? How is it possible? Is it possible that in future we can the Earth will stop and run into the different direction? Is it possible also that because of the magnetic pole can be changed from the north to the south? Can you explain to me, please?
Another question on Earth's core. Maybe you want to answer both of them together. Apparently, the Earth's core is slowing down. What does that mean for us? Clearly, we're all on the same page, Earth's core being that page this morning.
Hi, Yunus. The sort of topic has been pushed up the agenda because there's some studies being published at the moment which are looking by using various measures to see inside the world about 6,000 kilometres down below our feet to where the Earth's centre is, to look at the behaviour of the molten core which is inside the Earth. Now, the planet isn't solid all the way through, and it's not made of the same stuff all the way through. There are different layers to the Earth's surface and innards, and we know that because measures like seismometers, which measure vibrations, can track the passage of vibrations from earthquakes through the Earth, and the vibrations follow different paths by bouncing off of different layers inside the Earth. This was an insight by a Croatian scientist who was called Mohorovicic back in the 1800s, and he did the most amazing calculations down to about 6 or 7 decimal places in order to be accurate enough and precise enough to make these sorts of measurements. And it was him who had the first insights for what's inside our planet. The bit that we all walk around on is the crust and continental crust. And those crust plates are very, very thick indeed, tens to hundreds of kilometres. And beneath those is a structure called the mantle. The mantle is a more liquid, spongy layer, which, when you see the crust moving around on the surface, gets squidged and pushed out of the way. And when you have a high pressure in the mantle, it can deliver magma, which is where you get a volcano. Beneath the magma, beneath the mantle, which goes down a very long way, you get to first the outer and then the inner core. And what's in there is molten material, some of it liquid, but then inside that, a solid body. And this is where the heaviest stuff that formed the planet has gone. This is chiefly molten iron with a few other bits and pieces added to it as well. The reason it's in there is that when the Earth first formed, it was formed from very hot, mobile material, which as it coalesced together, under the impact of gravity, the heaviest things would have been pulled towards the centre more than the lighter things. So you'd have ended up a bit like when you put a plastic bottle in water, the bottle floats on the water. So the rest of the planet is floating on the heaviest material, which is in the centre. Because the Earth is turning and all the material that made the Earth is turning, as the planet formed about 4.5 billion years ago, that material would have continued to turn, which is why it still spins today. But because there are boundary layers that separate the hard, thick stuff from the runny stuff, you have effectively a bearing like you have on the axle of a car. So the two things can move independently, and they have this angular momentum, this spin. But it's possible because of the way the planet behaves and the embodied movements within those things, and as the questioner points out, the fact that we have a magnetic field called a geodynamo arising through some mechanism because of that spinning core, it's possible to induce forces in that and change its direction. And because it's not fixed to the rest of the planet, it can spin and turn in a range of different directions. What the implications for that will be, though, we don't know yet. We're not entirely sure. But because it has implications for the magnetic field which it generates, there will therefore probably be changes to the magnetic field. But this is not going to be a new phenomenon. We've known that the Earth has been doing things like this over a thousands to hundreds of thousands to millions of years to billions of years timescale throughout its existence. And you can see the evidence for that written into the magnetic fingerprints, which are in rocks dating back billions of years, because when those rocks were molten, they took on and aligned themselves with the Earth's magnetic field at the time. And we can read those fields in the rocks solidified today, and we know what the orientation of the rocks is. So we can work out where the magnetic field was pointing when those rocks were made relative to today. And that's how we wind the clock back geologically to see what's happened to the Earth over the last 4.5 billion years. So at the moment, it's an interesting observation. We don't know what the major consequences will be, though.
Sorry, Dr. Chris Smith on the line. The question about apparently the Earth's core is slowing down, and what does that mean for us? I thought since you're going there, maybe you could answer both those questions. They have popped up this morning. Have you answered that one too?
Well, the point about the Earth slowing down, if the Earth is slowing down, then the core is also slowing down. And the reason the Earth is slowing down and making days get slightly longer, actually, is because we have the moon. And the moon orbits around the Earth, so the Earth turns inside the orbit of the moon, and that's why we have tides, because as the Earth turns inside the orbit of the moon drags a blob or a bulge of water on the Earth's surface towards itself. There's also a complementary bulge on the other side of the planet, which is why there's 2 tides a day. But if you have that bulge of water, as the Earth turns, the bulge of water is slightly ahead of the position of the moon, and this means there are some frictional losses from the turning of the Earth imparted to the moon. So the planet as a whole is slowing down. So therefore the core by definition is also slowing down. But if you change the movement of the core because of other effects, because of the electrical effects and the dynamo effects making the magnetic field, this can also change its trajectory and movement as well. So there's a range of reasons why the Earth's core would be spinning at a different rate at different times.
Let's go to Barris in Bloberg. Go ahead with your question, Barris.
Morning, Chris. Now, just a question. Obviously, most of us, we walk around with our cell phones in our back pockets. Now, the question is it actually safe to do so? And is there any long-term harm in continuing with that sort of situation?
Hi, Barris. Well, the signal coming out of your mobile phone is a microwave signal. It's not dissimilar to what's running the Wi-Fi around your house or cooking the food in the microwave oven in your kitchen. It's a similar sort of set of frequencies. The microwave source in your pocket is quite a strong one because that phone has to communicate with a cell phone tower, which can be kilometres away, and therefore it does have to emit quite a strong signal. But the microwaves that it's using are used in the context that I've described because they're judged to be safe. Now, what we mean by safe is a relative thing, because at the moment no one has found any evidence of adverse health effects. There are certainly heating effects. When those microwaves interact with your tissue, they impart energy, because some of them are absorbed by your bottom and other bits of your body, depending on where you keep the phone. And this means you will warm up those tissues, but we don't think that is associated with a health harm per se. At the moment, though, the jury's very much out. Now, I'm not saying that to be sort of inflammatory or provocative, but it's always important with this kind of thing to keep an open mind, but to be reassured by the data that we do have. What data do we have? We've got about 40 years now of usage patterns for mobile devices where we can really judge in excruciating detail what people's exposure to these sorts of signals is and what the health outcomes are. And it's actually one of the best dose-dependent studies that's ever been done. Because one of the things about saying something causes something to happen is you should, by the Bradford Hill criteria of causation, which is what it's called, be able to show as part of that there is a dose-dependent relationship. The more of the thing that causes the outcome you're interested in, then the more of those outcomes there should be. So the more you use a mobile phone, or the more mobile phones there are in use, the more of the health harm we should see. That's the logic. And when people have looked at usage patterns of mobile phones over the decades, and they've shown an increase in phone usage, an increase in phone usage time, and an increase across the social spectrum, we have not seen that being mirrored by a disease outcome that's occurring on at least the same time scale. So this reassures us that for the short term at least, there does not appear to be an association between phone use and those health harms. But what we may not be doing is looking for long enough yet. So obviously you keep looking for longer. Bear in mind with cigarettes, it took us half a century to prove categorically, thanks to Richard Doll and his colleagues at the University of Oxford, that it takes a lifetime of smoking to get lung cancer, because it was an outcome that took a long time to develop. So if you only look in a week, you could say, well, smoking looks very, very safe. I've looked after a week and I couldn't find any problems with it. Look over a lifetime, very different story. So that's why people are continuously monitoring these things. But at the moment, we're satisfied that based on the physiology and the biochemistry and the physics of microwaves, we're not aware of there being a health impact. But with long-term exposure, there might be. And that's why people keep on looking. But at the moment, we're reassured by the data that there isn't.
Let's go to Ronnie in Mowbray. He's been waiting for a while. Ronnie, go ahead for the Naked Scientist.
Hi, my question is, in astrophysics, what exactly is a wormhole, and do they really actually exist?
Hi, Ronnie. Well, when we think about the universe is a flat sheet. And that sheet is made up of a funny entity that Einstein viewed as space-time, because space and time are bound together by mechanisms we don't really understand. And space is huge. The universe is an expanding bubble, and the gaps between the things in it are getting bigger all the time because the universe is growing. But if you wanted to go anywhere in the universe, there is a speed of light limit. You can't go faster than the speed of light. That's a fundamental rule in physics. And with something the size and shape of the universe being so vast, you would struggle to get across the universe. In fact, there are bits of the universe that are now off limits to us because we could never get there. So how could you traverse enormous distances in the universe? Well, perhaps it's possible. If you imagine the universe to be a sheet of A4 paper, you could go from one corner right across the middle to the other corner, and it would take you a very long time if that were the universe. But what you could also do is roll the piece of paper up. So if I brought the two edges together, then instead of having to go right across the sheet of paper, I just traverse between one bit of the paper and the other, and it takes me the blink of an eye. This is the concept of a wormhole, that you in some way bend or reform space. So you bring very remote bits of space-time close together, and by going through this wormhole entity, you leave one patch of space and emerge somewhere else. Theoretical physics says you could do this. You would need a huge amount of energy to sustain, support and maintain such a thing, and you'd need the amount of energy in a star or two to do that, so it's totally impractical at the moment. But theoretically, you could do this, and you have to be very cautious, as one physicist said to me, because you can prove anything on paper, but making it a reality or proving it really exists is another matter. So theoreticians come up with clever ideas, and then astrophysicists and cosmologists then test them with real-life experiments to see if they can see evidence for their existence.
Let's go to a voice note. Joe, what do you have for us?
Good morning, Clarence and Dr. Chris. What makes a person able to sense when someone is looking at you? I've heard that we're even able to do this in our sleep. Is that so? And is this an ability that all humans have?
Dr. Smith.
A very interesting one, isn't it? Because we tend to have this experience, and then we turn around and, there is someone looking at us, and it confirms our suspicion. What we're doing here, though, is very often adding significance to a coincidence. Because how many times did you turn around thinking there might be someone looking and there was no one looking? But you don't remember those. So you tend to apply a lot more emphasis and remember the occasions when it did happen, but you ignore the ones and the times when it didn't. So part of it is that there is recall bias there. The other part of it is that when there's someone looking at you, they're probably looking at you for a reason, and you're probably a bit keyed up and worried about things for a reason. So perhaps maybe you're changing the way you behave because you're a bit on edge. And we're all programmed to look out for people who are behaving differently to normal. So more likely, by behaving strangely, you're making it more likely that someone will look at you. So that's part of it as well. So I think part of it is coincidence. Part of it is that you may alter your own behaviour. If you're doing something shifty and furtive, you're more likely to get people looking at you, and you're going to feel a bit on edge because you're doing something shifty and furtive and know that you shouldn't be, or that know that things could be dangerous. And that's why you then tend to look round, and unsurprisingly, there might be the odd person looking your way. So I think there's a range of explanations for this. As to whether or not we do this in our sleep, again, I think probably if you were dreaming that someone was staring at you or looking at you, and then you woke up and noticed that they were there, you'll remember the time when you woke up and there was someone staring at you. The number of times you wake up, probably at least once a day, hopefully, sometimes more, and you don't have that happen and you just dismiss it. So it's, again, recall bias, I think.
And the question about the end of times or a possible cataclysmic event, Earth has seen a couple of those as well. You want to respond to that?
Well, we've certainly had a number of different crises on Earth over the course of the planet's history, but it's been here for about 4.5 billion years, and we're pretty confident it's going to be here for another 4.5 billion years. Most of the big impacts and bad things for our planet happened when it was very young, when the solar system was first putting itself together and all the planets and other bodies were jostling for position. The next major threat, putting aside what we're doing to the planet, for the planet itself, because it'll be here regardless of whatever we do. It just won't necessarily have life as we know it on it if we carry on the way we're going. But the next major threat for the Earth is our own sun, because although our sun is a long-lived kind of star and will burn for about 12 billion years, it's roughly halfway through its life at the moment. As it burns off more of its fuel and gets hotter, it will puff up and it will turn into what is called a red giant. And that red giant will become so big that the sun will stretch from where it is at the moment right out to the orbit of Mars, which is the next planet out in the solar system. So all of the inner rocky worlds will be completely engulfed and consumed by the sun. And that's destined to happen within about the next 5 billion years or so. Hopefully we'll have invented a way to solve the problem by then, by leaving the premises. But in the meantime, we just have to accept that one day our Earth is going to be sizzled up. So certainly the sun's going to rise not necessarily from the east or west or both. It's going to rise from everywhere and eat the planet.
Okay, Clarence, I know it sounds like a very stupid question. There's no such thing to ask Dr. Chris, but why does time seem to be going past quicker? Older folks said, as you get older, you think that, but people of all ages say so nowadays. That's the question. Dr. Chris Smith.
People say, and if you ask people who work on the psychology of timekeeping, and people have done experiments on this, they'll say it's because of the way that the brain processes information and the degree of novelty and stress sometimes to do with the tasks day to day. When you're very young, things seem to take forever to happen because the proportion of things that are happening that are new to you and therefore require a lot of processing in your brain, for you to remember a lot of things, for you to take away a lot of information and experience from the passage of time, the proportion of that is much greater than as you get older. And so when your brain considers how much information it's got stored for an event, it tends to use the density of that information to adjust for how long it thinks things took, because it uses the relationship, well, I know roughly how much information I'm storing about a day, what my memory density for the day is, and based on that sort of ticking memory clock, if I've got this much memory for an event, it must have taken about this long. And when you have an experience where things become suddenly very scary, very stressful, very emotional, you're making a lot more memories for those events, because they are requiring a lot of brain processing, or they're making a big impression on you, or they're very novel. And so when your brain looks at them, it thinks, I've got all this information, that must have taken ages. And so as a result of that, people tend to say they have a very fine-grained memory, and time dragged on over the course of something awful happening, or something, et cetera, et cetera. When you get older, of course, the proportion of experiences which are genuinely novel is much lower, because you've quite literally seen it all before. And so you're not storing quite as many memories, and you're not having to give as much cognitive processing to things. So the days seem to race by, and it gets worse the older you get. And so, I remember being desperate to reach the age of 10. It was taking forever to get to age 10. And then the next 10 years went a bit faster. And then the 20 years after that, I don't know where they went.
And they're going to get even faster. They're going to get even faster. And just like that, the time has flown by as well. It is nearly 3 minutes to 10 o'clock. And time for me to thank Dr. Chris Smith for this regular interaction on a Friday at 9:30. And the Naked Scientist, of course, doctor and scientist and host of the widely popular Naked Scientist segment